Ma'am, your voice was breaking. I'm not sure if you were trying to say something.
Breaking.
It's not quite audible. I'm not sure if the others can hear you.
No, we can't hear you, ma'am.
Can you hear me now?
Yes.
Good morning, Dr. Datta.
Yeah, good morning, ma'am.
I think we can add the participants. We can start off the session right away, right?
Yeah, sure. You let me know once the participants are added. I'll start it. And let me just pull out my PowerPoint presentation. Give me a moment.
Yes, ma'am. I think we'll do a test run to see if Dr. Swaroop can share his screen, and then we'll add all the participants.
I think if sir want to share, we have to stop the current sharing.
Stop the current
Yes.
sharing.
We admit, ma'am, parents have started calling.
Yeah, we can admit. I think I'm ready with my PPT. I just share it straight away. It's opening up.
Can I just add the participants?
Yeah, sure.
Yes, add the participants.
Good morning, ma'am.
Good morning. Good morning, ma'am.
Good morning.
Siobhan, I have muted you. Muted everyone. Unmute and speak.
Yes, thank you, Suhasini. Good morning, everybody. Thank you so much for joining us. We will be starting our program in 2 minutes from now. Please ensure that you keep yourselves on mute throughout the session unless one of the hosts unmutes you. All right. Thank you so much. Yes, Dr. Swaroop, I can see your presentation. Thank you so much.
So let me know when the participants are there in the room, and then I'll start right away.
Sure, doctor.
So I think you can stop sharing now because we have another PPT.
Yes.
Yeah.
We'll begin with our PPT and then we'll continue with yours. Thank you.
All right. Should I stop sharing?
Yes, sir.
Yeah.
Siobhan, I think you can start the session.
All right. Yes, ma'am. Has everybody been admitted from the waiting room? Yes. Good morning to our spot preliminary qualifiers. My name is Siobhan, your host for the Vikram Sarabhai Science Foundation Science Promotion Orient Test virtual classroom sessions. On behalf of VSSF and SPOT, let me extend our warmest congratulations to the schools, principals, science teachers, and all you students for having qualified the National SPOT Preliminary Exam for 2021-2022. The extra time, effort, and hard work that you put in has definitely paid off, and you can be delighted of the fact that you are one among the top 1,000 science talents shortlisted from across the country. So if you'd like to give yourself a huge round of applause, please do that. You can pat yourselves on your back as well. Not just you, but for your parents and teachers and all your mentors who have supported you and encouraged you to pursue your interest in the field. Before we move on, I'd like to extend a heartfelt apologies on behalf of VSSF because of a technical glitch in our session yesterday. We were unable to attend to sort of allow more than 100 students to enter the virtual meet. However, that glitch has been rectified, and we sincerely apologize for the inconvenience caused. I would also like to appreciate the parents for bearing with us and being so patient, because I know it is difficult. We all have other classes to attend, and it is difficult to reschedule. But thank you so much for bearing with us and for cooperating and for turning up today. That's the most exciting part. Suhasini, can you please switch the slide? Yes. Now, before we proceed, I'd like all of us to keep a few housekeeping rules. The first being this session would last for 1 hour, 1.5 hours maximum, right? The second point is that all mobile phones are to be switched off or on silent, right? And let's ensure that we keep our microphones on mute as well, unless one of the hosts unmute you to ask a question or to answer a question. The third point would be that I request all our students to be active participants in the session, to listen, and sort of come up with your own reflections, to draw insights, because our topic for today is to foster a scientific temperament, right? Questions from this session could be part of the spot final exam, except for the spot basic students. So ensure that your listening skills are on point. And this is a sincere request. Please don't doodle on the screen or in your chat, because otherwise, unfortunately, we will have to restrict your participation. Unless the speakers or the resource people ask you to sort of doodle or show a demonstration, then you can. But otherwise, we'd ask you to restrict yourselves from doing so. I hope all the rules are clear, and I'm sure that we will all follow them to the best of our ability. Before we move into the much awaited part of our session, I'd like to introduce you to our Executive Director of the Vikram Sarabhai Science Foundation Initiatives, Mrs. Suchitra Shaidjint. Ma'am, please, would you like to share a few words before we move on to introducing Dr. Swaroop?
Yes, thank you very much. And warm good morning to all these bright participants of Spot Basic today. So as already mentioned, you are the most privileged in terms of your aptitude in science. It is because you love science that you are here today. So that makes it very special and very, very welcoming for all of us. So as already shared to you in the preliminary note, in the preliminary address about the housekeeping rules, I would just like to add on the emphasize on the third part: be active listeners, be participatory in the session. So let me tell you, children, this session is exclusively for basic category of learners. In the past, whenever we used to have sessions, we used to have club session. But then we thought, if we want to make the best learning happen, it has to be within small groups. And that is why basic category learners are clubbed together. Now, just giving you a brief about what exactly VSSF is for. VSSF is to foster science. It's to create a liking towards science, which has been started by our very beloved, Dr. APJ Abdul Kalam. You all have heard about Dr. APJ Abdul Kalam, right? Shreyas and Garima, you all have heard about Dr. Kalam, yeah. So he started this in the year 2012. And from then on, we have been in a mission to identify students like you who like science, who learn science, who want to do something through science. So that is the objective of VSSF. And we have been mentoring students. And believe me, we have been seeing such tremendous positive learners who are pursuing science so seriously. So this is not for passive science learners. This is for active science learners who want to do something in science. So that is why you have written the spot examination and you have qualified in the preliminary examination. Now you have the bigger task. You will be facing another examination, which is the spot final examination. And this is just to give you some idea of various aspects of science. That is why these mentoring sessions are being scheduled. And there would be 5 mentoring sessions, which would be taken in 5 branches by people of eminence at your level, so that you can understand and you can think about it. Hearing is not what is required. Hearing and reflecting is the most important thing in science. So science is not something which is there in your books. Science is everywhere. Science is behind where duty is sitting. Through the window, if you look out, Duty, you will see signs. Aram, you will see signs around you. You can see signs in the kitchen. So basically, science is everywhere. That is a realization what we want to give all of you. And today and the subsequent few days, you would have got the schedule. Subsequent few days, you will be having continuous session, and I'm sure your perception of science, your liking of science would definitely grow multifold in the days to come. So our endeavor, dear kids, is to create a liking, because you may be 9, 10, 8, 9, 10, 11 years of age. There's a long way to go. If you start loving science, if you're passionate about science, believe me, after 10 years, by the time you graduate, you can do something prospective through science. Anything, something prospective through science. That is the objective of BSSF, to create learners who can do something through science. You can make changes through science. You can make innovations through science. You can help humanity through science. You can help agriculture through science. So I do not know, or we do not know what's your interest, but we will definitely give you more options so that you will start thinking in that level. And that is the main objective of BSSF. Yes, Arav wants to show something. You please, we can't read it though. So basically, we want you to be participating wholeheartedly in all the sessions, interact with the resource persons, and that is the objective of this kind of get together, or a session like this, where we can interact with each other. So this is what I would like to tell you. I would like to wish you all the very best in your starting journey to science. You've just started science. There's a long way to go in your starting journey to science. So all my fellow resource persons would handhold you, would help you, would help you build the understanding of science. Today, you have a session on how to develop scientific temperament in your very preliminary learning phase. That is the topic. I'm sure you will have a very, very enjoyable session. Um, so all the very best to all of you, and I hope you will pursue you will pursue a journey in science. I can't read my, I have a test. Okay, whatever is there, you put it in the chat box. The team will revert on that. Thank you very much, and all the very best to all my dear little ones. You are 684 in number from across the region. So that itself is the fuel for us to take things forward. Thank you very much. All the very best to all of you. I know you have a lot of questions. We will be taking around 10, 12 questions today. Whatever questions you have, uh, we will pick out 12 questions from that, and we will allow you to ask out here. So you can type your questions with your name, with your school and your state, and the host or the coordinators would give you an opportunity to ask the question. So thank you very much. I hand over the session to Siobhan. Thank you very much. All the very best, kids. And let me tell you, we have the first session is with Dr. Swaroop Datta. I'm sure you would enjoy his session, and you'll have a new perspective about science by the time, it's 11:50, by 12:15, you'll have a different perspective in science. So over to you, Siobhan. Thank you very much.
Thank you, ma'am. Thank you so much for sharing light on how we can, foster the scientific temperament in our day-to-day life. It doesn't matter what age we are, we can always start young. In fact, that brings me to the introduction of our topic today, which is, as I mentioned earlier, fostering scientific temperament. Now, to all of us at Vikram Sarabhai Science Foundation and all our resource partners, we firmly believe that a scientific temperament is a way of life. At its core, if you think of it, the scientific temperament calls for a keen sense of observation and an inherent curiosity. We don't take things at face value just because somebody says so. We always try to find out why and how things occur. If you think of yourselves as children, or anybody for that matter, all of us were once, infants or children, this sense of curiosity and this sense of observation is at our very core. It is our instinct. A baby, an infant, if you've noticed, if you sort of snap your fingers, the child will turn towards direction of sound. Why? Because the child is aware that there is a sound. The child is curious from where this sound is coming, and the child wants to understand the sound, which is why the child sort of turns their ear in that direction. If you sort of, put your finger, I don't know if you've seen this, but if you put your finger at the palm of a child, they will quickly grasp it, again because the child is curious of their environment. They're curious of this finger, they're curious of whatever objects you put in front of them, which is why we feel that it is in our very blueprint, right? It is it is a way of life, and we should sort of be encouraged to nurture this temperament that we have right from infancy as we grow older. But what most often happens is, as we tend to grow older, we sort of lose this curiosity that childhood comes along with, and we sort of lead ourselves into just accepting what the world says, or going by the herd mentality. The importance of the scientific temperament is that it teaches us, like I said, to observe and test our perceptions before agreeing on a rigid attitude or a judgment, right? So we test, we retest, and then if it doesn't serve our reasoning, we sort of discard it, because change is important and inevitable, and the scientific temperament will enable us to change what cannot be verified, and also what is not necessarily the most effective in our society today. Our first Prime Minister, I'm sure all of you know, Pandit Jawaharlal Nehru, firmly believed in the scientific temperament, right? And he said that no country, if you're looking at scientific temperament from a social perspective, he said that no country or people who are slaves to dogma or dogmatic mentality can progress, which is why we sort of want to encourage all our children to, sort of form a perception about a particular theme or a topic and test and see how it reasons or how it can be verified. And if it cannot, then we sort of alter our judgments. So that leads us to being more open-minded, more objective, right? I also remember in one of Dr. Swarup Datta's earlier sessions, I very, very fondly remember the statement that he said. He said it's important to research, it's important to test our hypothesis and validate it. However, what is most important is to sort of express our failures, is to talk about our failures, and that will lead us to a positive approach to failure. It helps us to persevere, and we sort of help all the other scientists in the field to sort of take off from where we left off. So it's very important that when you're doing an experiment, you might fail 100 times, but you talk about your failure so that all of us can learn from it, right? And Dr. Swarup Datta is probably the best person to lead us into our topic, which is why I would like to welcome Dr. Swarup Datta. He is the recipient of the Young Scientist Award in 2007, a Master Black Belt in Lean Sigma Quality Management Systems, and also a certified Green Belt and Global Career Counselor from ULCA, and a Master Practitioner from the Global Science Foundation. Dr. Swarup Datta is extremely enthusiastic about working in the field of education, nurturing young talent, and also at the management level. Dr. Swarup, you certainly are a privilege to have with us, and I honor you and welcome you to our session today.
Thank you so much, ma'am. So, should I move ahead?
Yes, sir. You can start sharing your screen since we have stopped sharing our screen.
Right. And before I share, let me just inform that I have been, cut off a couple of times. So just in case I get disconnected because of network issues, I'll definitely join back from an alternate network.
Sure.
So give me a moment before I share my screen.
Yes, sir.
So a very good morning to all the future scientists of our country. I can see your enthusiasm reflecting not only on your faces, but also in the chat box. So I'm pretty sure you all are eager to learn more about science. And today's topic is developing a scientific temperament in students. Now, I'll also speak about a few different branches of science after we have completed this PowerPoint presentation. And then we can also understand what scientific temperament is and what are the different branches of science that we can be in. Now, what exactly is scientific temperament? We need to understand that. Scientific temperament refers to an individual's attitude of logical and rational thinking. So, as you can understand by the definition itself, it's an attitude. What type of attitude? The way you think. So, your thinking can be of different types, but when it is based on logic and rationality, what is logic again? Logic is your thought process governed by existing sources of knowledge, whatever has been discovered so far, whatever has been invented so far, whatever are proven laws. Based on that, when you think about something, it's called a rational thinking. And most importantly, a rational way of thinking is when you just do not say your thought in a very utopian manner. You try to experiment, you try to observe, and then you try to analyze your observation and share what exactly you think about those observations based on current state of knowledge of the world. So an individual is considered to have scientific temperament if she or he employs a scientific method of decision making. Now, this is another very important one, scientific method of decision making in everyday life. Now, Suchitra ma'am was telling you in the very beginning that you see science all around you. Everything is science, right? We are talking with each other through science because we are talking, using a technology, internet, laptops, mobile phones. I am connected to you through science. At the same time, I'm holding a bottle in my hand, which is again a result of science. There is light in my room, which is again because of science. So basically, if there is no science, we would have still be in the age, the age of the cavemen. But even then, that was also science. Even the cavemen, when they were hunting, they used the tools for hunting. That was a result of rational thinking and implementing that thought to hunt down an animal which was stronger than the human beings. So science is basically all around us. That is something that we need to understand. Now, how capable are we to look at science? That is the question. And everyday life, we have to do a lot of things. You get up in the morning, you brush your teeth, you take your books out, and then you start studying, attend online classes. Throughout the day, you are interacting with science all the time. And then you take so many decisions in the course of the day, right? So these decisions are correct ones, provided they are governed by scientific method of decision making. Now we will understand what typically is a scientific method of decision making, but as for now, understand this thing very clearly, that when I am making my decisions, I'm solving my problems, I'm interacting with things, I am answering questions that is based on existing state of knowledge. That is called a logical and rational thinking.
Sir, if I may interrupt you in between,
Sure.
we're unable to see your second slide. We're still seeing the first slide.
Are you not able to see the second slide?
No, sir, it's still on your
Okay,
introduction slide.
Give me a moment.
Students, I would request you to kindly mark your attendance on the Google form that has been shared with you. Please ensure that you sign up your attendance for today's session on the Google form that has been shared with you.
All right, I think there was a technical glitch while sharing the slide. Now, is my slide moving?
Yes, sir. Thank you so much.
Yeah.
Yes.
Yeah, thank you so much. So we were talking about scientific temperament and what exactly is scientific temperament. We have understood this much, that a scientific temperament is an attitude based on logical and rational thinking of the existing state of knowledge that we have reached. Now, scientific temper involves, what are the things that scientific temper involves? The first one is the method of science provides a practical method of acquiring knowledge. Now, we cannot just acquire knowledge from the books, you know. So if you just read books and think that that is the ultimate source of knowledge, we are mistaken. The ultimate source of knowledge is not the book, but the real world. How the books were written. The books were written because something happened in the real world, and that was written in form of a story or an incident narration or an explanation that was deduced. And those explanations were written down in a book and shared with you. But before that book was written, something happened somewhere, right? So whether it's the electric bulb that Edison invented, or an electric steam engine, or the internet was being invented. So anything in the world, whatever has happened, that is being noted down in form of a book, and you're reading that book. So what does it mean? That real thing is happening in the real world. So the human problems can be understood and solved in terms of knowledge gained through the application of method of science. So, and why science is important? Because we are solving problems. Do we really have problems all the time? Yes, we do. What type of problems we have? We want to live a better life than what we are leading today. So that quest of leading a better life, more comfortable life, more convenient life, science plays a very important role. And that is the reason, the different ages, starting from the Stone Age, then Copper Age, Iron Age, all these ages has proven that human beings always wanted themselves to be developed. They want more and more in terms of, the convenience of life. That is the reason they first learned to hunt down food, eat raw meat, have raw fruits, vegetables. Then they learned how to cultivate. Then they learned how to cook. And now we have moved to the point of, cooking fast food as well. So they wanted it to cooked and they wanted it fast. So people, some of you, I just saw that you wrote in the book, in the chat box, that you want to be an entrepreneur. So what is an entrepreneur? An entrepreneur is a person who, invents or discovers a new solution to a problem and sells that. So everything, if you want to be an entrepreneur, you need to be a scientist as well. You must have heard about Steve Jobs. He changed the way the mobile phone operates. So the Apple phone is one of the most expensive phones in today's world. Similarly, when we are dealing with computers, the Microsoft software itself, it made life so much easy. When I was in school in your age, there was no computers. I remember when I went to class 9th, and that time computers first came to India. In terms of not only India, it came to schools, I would say. So we were operating computers using something called floppy disks. I don't know how many of you have seen a floppy disk, but there was no software, no user interface like Microsoft. We used to put in sort of a plastic device inside the computer, and then we used to operate it. So that was so difficult. And the entire computer screen was not colored, it was black and white. So this is something you can see in the DOS command. When you give that type of screen was there. Now we have developed to a certain extent that today I can watch a movie on my computer, or watch Netflix or something like that. So that is the progress that science has made. Next, when we talk about scientific temper, we also talk about the fullest use of method of science in everyday life and in every aspect of human endeavor, from ethics to politics and economics, is essential for ensuring human survival and progress. So science is basically not an isolated branch of knowledge. Science, as it was said in the very beginning, is everywhere. Science is there in politics, science is there in economics, science is there in human survival. Now, we have seen very clearly what the last line means. Science in human survival. We are going through a pandemic. And in that pandemic, we all know what is or was the importance of the vaccines being discovered or invented. Now, till the vaccines were there, we all were so scared that when the vaccine is going to come, when we will get vaccinated, and when the death rate will drop down. So it took the scientists around 11 months to come up with a vaccine. And then after that, a few months for the country and the other world to be vaccinated. And today we see that the schools are reopening again. And people are, the death rate has reduced considerably. What made it possible? Apart from science. It was all about science, right? That is allowing us to survive this pandemic. Next. So, you have to also understand that scientific temperament involves that one should accept knowledge gained through the application of the method of science as the closest approximation of truth at that time, and the question what is incompatible with such knowledge. So what is the meaning of the sentence? The sentence meaning is that whenever you accept a knowledge, you will ask yourself, is this true or is it false? So when you say it's true or false, based on what you will say that? It's not based on your assumption that I feel it is true, so it's true. You cannot say that. That is not the way scientific temperament works. So what will help you to decide it's true or false? It is the existing knowledge of science and the scientific method. So scientific method, I'll talk about that in detail a little bit later on. But how closely it fits with today's science is, you can say, the logical explanation based on scientific facts. So we all know, let's say, light travels in a straight line. Now, if someone tells you, no, light travels in a curve, is it true or false? You will say, no, it's false, because we know today by different experiments that science has very clearly shown that light travels in straight line. And you can pull out experiments. You can do an experiment and show it to others also, that how light travels in a straight line. So how you are reaching that conclusion? Based on what you have learned from the research of other scientists, other people who shared their knowledge. That is how we all learn. If one person was to, come up with all the knowledge, he is the only person who will share his knowledge, world would not have progressed. We stop and see what others have shared, we learn from that, and then we come up with a new thought process. That is what science does. So one should, from time to time, re-examine the basic foundations of contemporary knowledge. Now, what does it mean? That whatever is told to you, you will accept that based on logic. But if your logic does not permit you, you say, no, I think it is wrong, it's not right, then you can do your own experiments and you can show others why the previous knowledge was incorrect and what you are telling is correct. Give an example. For example, you must have heard about Galileo, right? So what happened to him? At that point in time, it was said that Earth is the center of the universe and the planets and the sun revolves around the Earth. That was what even the Bible believed, or the church believed, I would say. But then this scientist comes up with the thought that no, Earth is not the center of the solar system or the universe. In fact, Earth is a planet and sun is in the center and the Earth revolves around the sun. You know what happened to him? He was sent to the prison for not accepting the existing knowledge. They said, you are blasphemous. You are not obeying what we are telling you. It's existing knowledge. We say that sun is not the center, Earth is the center, and the sun revolves around the Earth. Galileo, when he was being sent to the prison, he stamped his feet 3 times and said, you can send me to the prison, you can even kill me, but still the earth will revolve around the sun and not the sun around the earth. So that is challenging the existing knowledge. And today we all know that the earth is a planet that revolves around the sun and the sun does not revolve around the earth. So at times you will understand that you can challenge existing knowledge to share your own knowledge, and that will be accepted as true. Indian Constitution also talks about scientific temper. Now, what is this article of the Indian Constitution? Article 51A of our Constitution, which deals with fundamental duties, makes it a duty of every citizen to develop scientific temper. As per the clause H, it is the scientific temper that helps in developing secularism, humanism, and spirit of inquiry and reform. Now, when you think logically, rationally, scientifically, what happens to you? Your observation widens. You are not restricting your observation to look at things the way you feel it is. For example, you're walking on a road, you see a rope, and you think it is a snake. You know, at the night, at times it happens. There's a pipe somewhere on the road, it's raining, and the pipe looks like a snake, and you say it's a snake. You believe it's a snake. But then someone who is scientific minded will go close and check if it is a snake or something else. Now, when he goes close and observes, he is observing with an open mind that it can be a snake or it may not be a snake. Then he finds out the reality. But one who says that, no, I have seen that it's a snake. There cannot be anything else. I'm not even going and seeing it. So what will happen? Even if it was a pipe that was there, rubber pipe, he would have still thought it's a snake. People try, even if they try to tell him that's not a snake, it's a pipe, so much fixed idea he will have that he will say, no, I don't accept what you're telling. I saw it's a snake, so it's a snake. So science or scientific temperament is all about going close and checking it out, finding it out whether what I'm thinking is right or is it wrong. Then when you have an open mind, you look at things from a different perspective. You look at a religion from a different perspective. You look at humanism from a different perspective. So this is what scientific temperament can do. Scientific temperament widens your observation so that you can think rationally, logically, and take the right decisions. So our Constitution also talks about, developing a scientific temperament. National Science Day. I think you know about this, right? It's approaching us. The government of India, through the National Council for Science and Technology Communication, dedicated the 28th Feb as the National Science Day. And in the year 2014, the theme fostering scientific temperament was taken up. Every year, the National Science Day has a theme. For example, this year, 2022, the theme is Integrated Approach in Science and Technology for a Sustainable Future. So in 2014, the theme was fostering scientific temperament. And as a lover of science, each one of you can celebrate the National Science Day, which is 28th of February. Now, the question is now, I have spoken enough about scientific temperament. What is scientific temperament? How you can develop it inside you? That's the question, right? So how we can become scientific minded? The first, I'll give you a few tips. I'll not make things very complicated, very lengthy. I will try to give you simple solutions so that you all become scientific minded and develop a scientific temperament, right? So are you interested in doing that? If you're interested, raise your hand. Let me see how many of you are interested in learning the scientific temperament, how to be scientific minded. Great, wonderful. I can see the hands going up. Fantastic. So see, this is a picture. Can you identify whose picture is this? Let me see. How many of you can identify this gentleman? Type it in the chat box. Let me know from the chat box. Who is it? Absolutely, spot on. Albert Einstein, right? One of the most well-known scientists that we have ever heard of, right? So Albert Einstein, I'll share a small story about Albert Einstein as well, so that you can understand how you can become a scientist and what type of skill sets you require. Are you aware that Albert Einstein came up with theories of relativity and a lot of big concepts that probably you will read when you grow up? But are you aware that when Albert Einstein used to go to a place to deliver a lecture, he used to stay in a hotel, and often his memory was so weak, he used to forget which hotel he is staying in. So he used to go out in the market, and then he forgot which hotel he is in because his memory was weak. And then he used to ask people. In those days, there was no television, and media was not so publishing everything. People did not recognize Einstein by his face. They have heard about Einstein because media was not so developed at that point in time. So because people did not know him, when he was moving around, he used to ask people the name of the hotel by asking them, do you know which hotel Albert Einstein is staying in? Then people could not recognize him as Albert Einstein, but they know, or they knew that which hotel he was staying in. So they used to show him the way. Okay, Albert Einstein is staying in that hotel. So he used to slowly come and go to that hotel. So what I'm trying to say is, with such poor memory, think about what he has done. So if you cannot remember things, it's not that you cannot become a scientist. Becoming a scientist does not require you to mug up things. Remember by heart. So how you can become a scientist? Einstein has written on the board itself, question everything. Ask question about almost everything and seek out answers on your own. That's the first step. Do not try to get the answer very easily from Google. It's there in your fingertips. I know that. You're holding a smartphone or a tablet or a mobile, this laptop. You can Google it up, but don't do it. Try to think. Because the moment you start Googling up, your thought process becomes rusted. You see how iron becomes rusted when it's not used? You need to use your brain. Your brain is nothing but connection of nerves, neurons. So these connections only function when you use them. If you do not use those connections, the connections gets disconnected and you lose your, the power of the brain. So first thing you need to understand is question everything and search for an answer. Now, how to question everything? For example, you're driving in the night and you see two bright eyes in front of your car. Now you saw that, oh, it was a dog or it was a cat. Have you seen that ever? You're crossing a dark road, all of a sudden, two big, bright yellow lights, eyes in front of you. If you've seen that ever, you just check it out. At times it may happen when you're moving around in a car that you see this type of things. And then you see that the eyes of these dogs and cats glow in the darkness. Now you can ask yourself, why does that happen? I'm not going to give you the answer because that's the barrier to develop a scientific temperament. So today I'm posing these questions to you. Why the eye of a tiger or a dog or a cat glows in the dark? What is there in the eye? Try to think and find it out. And then you can finally check out the answer in your book or in your Google. But before that, try to think. Yes. So in what way you can start thinking? That the eyes glow, maybe two things can be there. One is it has something like a mirror that reflects the light, or it has a chemical inside it which glows when the light falls on that. That's also a sort of reflection, but what the eyes contain. So when you go deep into it like this, you will come to the conclusion, what is there that makes the eyes glow? Or, what is the reason we see rainbows in the sky? After, a rainy day, when the sun just comes out, we see a rainbow. Have you seen a rainbow, everyone? Yes? Right. Now, what is the reason the rainbow forms like that? Why the shape of the rainbow is like in that arch form? Why it's not a circle? Why it's not a square? Why is it arched? Right? So these type of questions you can start asking. And then you try to find the answer yourself. Think. That is the first step of developing a scientific temperament. Now come to the next point. Develop critical thinking skill, So doubt the well-established ideas. Now, as a scientist never accepts something on face value. Just like I told the example of Galileo Galilei, right? He did not accept just because in those days people used to say that the sun revolves around the earth. He did not accept it. He said, I will find out if it's true or wrong, false. So you have to doubt, you have to question, you have to doubt that is it this way or there can be another way. So use your reasoning and ask yourself questions like, is there a way to prove this? Is there a way to prove this? We say light travels faster than sound. You have heard about that, right, students? Light travels faster than sound. Now, if I tell you prove it? Can you prove it? You have to start thinking, that how can I prove that light travels faster than sound? So when you think in that way, you start proving things, you are developing scientific temperament. Or you can take simple things, for example, your house is being painted. Now, there are packages of paint that has been purchased, and the painter has opened it up and started painting. And you get a different smell from that paint. You ask yourself, what is that in the paint that is smelling like this? What is there? What is the chemical that smells like this? Then you try to investigate, right? Or you can question yourself, if I want to make a color like, green or blue or red, is it one single color that we use, or we can form that color by mixing different colors? So simple questions, simple things you can doubt and ask. Gain knowledge, but try to marvel at mysteries that are yet to be solved. Fine. That's another very important thing, You gain knowledge that is there in the books. Your teachers are going to teach you. You learn a lot of things from the YouTube, internet, everything. Fine. That's perfect. But try to question the mysteries that are yet to be solved. What type of mysteries are yet to be solved? Even the function or power of the human brain is not discovered. We know only 20% of the brain's capacity. 80% is still unknown to us. We can go into that domain. We can think about what is a cure to a deadly disease like acquired. Am I audible, children?
So we lost you for a moment.
Oh, okay.
Just the last bit.
Am I audible now?
Yes, yes. Thank you.
Yeah. So what I was telling is that when you gain knowledge, the existing knowledge you are gaining because it's already discovered, someone has found it out, it's written on the book, but then try to find out answers to the questions that are not yet answered. Examples. Now let me just put this in front of you. Instead of me doing all the things, let me check if you know about certain things whose answer we still do not know. Let me see how many of you can, talk about that. Let me, you can put the question in the box, chat box. Things that are still not known. What? Or a few things you can point out. Type it in the chat box. Let me see. What is your answer? Bermuda Triangle. Okay, very good. Bermuda Triangle. You want to find out about it. Good. So it's not answered. Riemann hypothesis. Okay. Cancer cure. Wonderful. Dark matter. Great. Can we not die? Wonderful question, Madhav. I love that. Can we become immortal? Yes. So far, people say no. Anyone who has been born has to die. But can there be a way to make yourself immortal? White holes. Are aliens real? Wonderful. See, so many wonderful questions you're putting on the chat box, right? What is dark matter? Great. Wonderful, wonderful. How humans were created. Is there a life or, is there a life or on any other planet beside Earth? See, wonderful question. Existence of wormholes. Great, great. So you see, you're coming up with so many questions. That's what science asks you to do. Question for the mysteries that were not solved, right? In one of the sessions I took for VSSF, I told the children, how your entire brain can be put inside a software and loaded in a computer. That is, research is being done to make it possible. Now, when that happens, what are we? We think about everything through our brain, right? So if the entire brain can be replicated and put on form of a chip inside a computer, what will happen? Even if your physical body dies, your mind can still live. You can still think because your mind has been put on a computer. Now, is if that possibility can be made true, is being researched nowadays. So think about the research and intensity of it. Organ transplantation. Someone has a kidney problem, a donor has to be there who will donate the kidney that will be transplanted on another human body. Now people are coming up with new questions, that is it possible that through 3D printing, instead of printing out something through plastic or that fiber that we use for 3D printers, is it possible that we print out a kidney and put it in a human body? Now this is also at the verge of making a real possibility. It will be there within a few years of time. At your lifetime only, you will see kidneys will be printed, livers will be printed, and you don't need a live human donor to donate these things. So that will be the beauty of science and the beauty of thinking what can be made possible, what is not possible today. So a question like, why do sodium streetlights have an orange glow? He says that because the lamp emits lights that is orange. Yes, but why? Why does a sodium light emits a light that is orange in color? So questions like that will make you understand and go deep into a concept. Now, this is, you all know, an integral part of science. Experiment. Do it hands-on. Bring up things, pull out things from your school laboratory, things in your home, and then you try to do an experiment to understand that if a knowledge is true or not true. So stay away from finding answers on the internet and try to use your own reasoning. Create models or diagrams to explain your understanding. Now, this is very important. When you read a concept, just not write it down. Try to make a model of that concept. Make a diagram of that concept. Why? Because when you are making a model, you are practically implementing your knowledge in the real life. Just reading on the page through alphabets and words, writing down the things again on a page in form of alphabets and words is not the real intention of gaining knowledge. You gain knowledge to do something practically. So whenever you gain knowledge, it would be great if you can put that thought or that knowledge that you gained not only on paper, but in form of a model, in form of a diagram, in form of something that can solve the problem. Solve the problem of your house, your community, your neighborhood. You must have seen so many children coming up with products or services to solve a local problem. And these local problems, when solved, these children are selling that product and they're earning in millions. And these are not college students I'm talking about. These are students of grade 5, 6, 4. You never know at what age. Science does not have any age. You can be a scientist even at the class 3 level. It doesn't matter. You can think like a scientist. You can find out a solution. It all depends on how you think. And it will never be like, I grow up, then I become a scientist. That thought is wrong. You are already a scientist. The only thing is, are you using your scientific knowledge? That's the real question. So whatever you see, whatever knowledge you gain, try to make a model, try to make a diagram, try to make a product, try to solve a problem through that knowledge, then it is the real utility. Real life knowledge. Search for examples in real life applications while understanding the concept. Now you are being taught, let's say, addition in mathematics or percentage in mathematics. Now you will ask yourself, why am I learning this percentage? How will it help me? So it will help you. Let's say you go to a super shop, and it's like D-Mart or Big Bazaar or any other big shop, and there you see 20% discount is being given. Now 20% discount when it's being given, you will immediately you need to calculate, if a product is 100 rupees price, then what is the price which I need to pay? You will immediately come to the understanding, okay, 20% means 20 out of 100. So I need to pay 100 minus 20, that is 80 rupees only for a 100 rupee product. So here in real life, you're applying the knowledge that you gained in the classroom. Or let's say your teacher is teaching you surface area of a cylinder. Now you will ask yourself, why am I learning this? Why I need to know the surface area of a cylinder. See, you can think in this way, your house is being painted again, and is the external area of the house, the external building being painted, and there is a pipe that comes out of your bathroom and goes to the ground floor, an underground tank. Now your father told you that you bring some paint to paint that pipe as well. Now you go to the shop and they tell you that you buy the paint. Now you ask yourself, how much do I need to buy? I buy 1 tin or 2 tins or what? 1 liter, 2 liter. How much paint would I require? For that, you need to understand that what is the surface area of that cylindrical pipe, and then with that surface area, you can find out how many this 1 liter of paint can paint how much surface area. So you can ask the shopkeeper, sir, what this 1 liter of paint that you're selling me, how much surface area can it cover? So he will tell you, let's say 100 centimeter square or something like that. So when they say you something like that, a rough figure, you immediately calculate, okay, if 1 liter goes for this much surface area, then my pipe is of this length and this surface area, so I need 2 tins of paint. So based on that, what paint you would require, you can find out through the surface area of a cylinder. If you do not know the formula of a surface area of a cylinder, I'm pretty sure you have not learned about it, so I'm not telling you all the complicated formulations. But just to understand it, that if you do not know the formula of surface area of a cylinder, you cannot buy the right quantity of paint. So that is how real life application of science happens. So take knowledge out of your textbooks into the world around you. Just question yourself. Every time you read something in the book, ask yourself, why am I doing this? Why am I reading this concept? Why the teacher wants me to know the concept? And that why should not be the answer because it is to be written in the examination. The answer cannot be that. The answer should always be what I will be able to do after learning the concept. Examination is nothing, it's just a game. You know something, you just check yourself if you answer the questions or not, that's an examination. But your real test is what you do in the outside world. So always relate the knowledge that you gain with that of the outside world. Now, there are different sources of knowledge that you get on internet. Anything that you find on internet is not right. Anyone, any Tom, Dick, and Harry can write something on the internet and upload that as form of a website. Just because it is there on the website, it does not mean that it is true. You need to understand reliable sources of knowledge, which are the ones which are authentic. Now, I have shown you a few things. Can you tell me out of the 3, which one has the chance of not being authentic? Let me see. Which one has a chance of not being authentic? Is it the Khan Academy? Is it the Wikipedia? Or is it the YouTube? Where you can find...
Sir, your voice is breaking, but we can see your slide.
My voice is breaking. Others, can you just quickly tell other children if my voice is audible? Because I can see my full signal on the internet.
Dr. Datta, it is audible right now. It's fine.
Audible.
It's fine.
Fine. Thank you. So as I was asking, this Khan Academy, yes, someone has given the answer. YouTube, right? Absolutely right. Khan Academy, there is a responsible person, Sal Khan, behind Khan Academy. You know that whatever Khan Academy publishes, 99.99% of times, it is going to be true. Whatever Wikipedia publishes, it has tested knowledge put up over there. But YouTube, you take a mobile phone, shoot anything and upload on YouTube, it may not be right. It can be false knowledge, right? So very clearly understand to differentiate true knowledge, authentic source of knowledge from unauthentic ones. So only when you surf the internet, question yourself, whatever I am learning, is that website an authentic one or it's just an untested, unreliable website? So in that case, what will happen? On internet, there are thousands of sites that come up. You will make the right decision of selecting the right source of knowledge. Selecting the right source of knowledge is also scientific temperament. You need to decide which source of knowledge I will use and which source of knowledge I will not use. So when you do an experiment, you write an article, you give references of books, right? You will see, you take out any scientific paper. There are journals. I'm pretty sure in your school, there will be journals like, Nature. Nature is a magazine which is, very well tested. There are magazines like Lancet, which are well tested. Now, these magazines, scientific magazines, have something called impact factor. What is an impact factor? The reliability of the magazine and how much, how the world scientists look at that magazine, with what thought process. Do they accept whatever is published in that magazine? So Nature is a scientific magazine with high impact factor. So when you read an article from Nature, you will see the author has given, references. Now, all these references that he has given, you go to the references and check what are these books all about. You will see all these are well-tested, authenticated books that they are referring to. They will never give a reference of a book or an internet content that is not well tested and tried out. So when you conduct experiments, when you write an article, when you write your thought process down, something that you think you have invented, discovered, new knowledge that you created, what you need to do? You need to give reference only through authentic source that's available on internet or in your library. Now, this is another very, distracting thing that we have in these days, the television. Every house has its own television time, but what are you watching? That is very, very important. Let the TV time be more for scientific programs than for entertainment. Entertainment is required. I'm not, denying the fact that you need to, watch a movie at times or listen to a good song or view a song on the television. That's perfect. No problem with that. But if you spend your entire time for entertainment, it's not going to give you any result. And that is the reason another name for the television is called an idiot box. Why is it called an idiot box? Because when you're watching the television, it makes you an idiot. It converts your thought process. It just, shows you something on the screen and you absorb it without thinking if it is right or wrong. So you should focus more on channels like Discovery, Animal Planet, National Geographic, BBC Earth, and TV shows like, The Science of Stupid. This comes on the television. How many of you watch this show? I do not know, but try to watch this, Science of Stupid. It gives you a lot of inputs about scientific things. So do not let your television dominate your house in terms of movies and entertainments and serials, but science shows. Ask questions with a reasoning. You need to use your reasoning and ask questions like, why is this happening? Or is this the right way to respond? Who said this? Can I trust this instruction? So it means what? You are asking questions every time. So, asking a question is the first step to being a scientist. Question everything. That's what I showed you in the very first slide. So you can question how many different types of questions you can form. Questions with why, questions with how, questions with who, questions with when. So all these W questions, when you start framing, you gain knowledge in a more scientific manner, right? Now, this is something called, inductive and deductive reasoning. Now, for example, specific to general rules is called inductive reasoning. And a general rule or principle to a specific is called deductive reasoning. I'll give an example. Dogs have 4 legs and dogs have 2 ears. This is a general rule, right? So when you say dogs have 4 legs and dogs have 2 ears, you mean for all dogs. Now you have a dog which is a golden retriever, or let's say a German Shepherd. So you say that German Shepherd is a dog. So it automatically means that it will have 4 legs and it will have 2 ears. So when I say this, general to specific, when I say every dog will have 4 legs and 2 ears, when I talk about a specific dog, German Shepherd, it also means that it will have 4 legs and 2 ears. The other way around can also be done. You say, I saw a German Shepherd, it had 4 legs and 2 ears. I saw a Rottweiler, it has 4 legs and 2 ears. I saw a Pomeranian, 4 legs and 2 ears. I saw a Dachshund, 4 legs and 2 ears. I saw a small pug, 4 legs and 2 ears. So it means all dogs will have 4 legs and 2 ears. So that is from specific to general. So when you see too many specific things, you come up with a general conclusion. It's called inductive. When you see a general thing like a dog have 4 legs and 2 ears, you come to a specific dog, it's called deductive. So your knowledge can be, processed in this manner. You can either see a lot of specific things and form a general rule, or you can say a general rule is seen and you go to the specific. Now, when you do this, practice this day in and day out, you will learn the reasoning. Simple thing. I just told about a dog. Right now, you're thinking like, let's say, how can I think? No, this is a bottle I'm holding in my hand. When I see this bottle in my hand, I say a bottle is, cylindrical in shape. It has a cap. Now, I see 3 bottles which are cylindrical in shape, but then all of a sudden I find a bottle which is flat as well. It's not cylindrical. Then I say, no, most bottles are cylindrical in shape, but there are bottles which can be, not cylindrical as well. So we cannot frame a rule on that. But all bottles will have cap. That is a ground reality. That is something that is true. All bottles may not be cylindrical. There can be flat bottles. There can be square bottles. But whatever type of bottle it is, it will definitely have a cap. So that is how we come to conclusions. Inductive and deductive. So for your everyday life, you can think the things that you see around you. Can you make it general? Can you make it specific? Go from general to specific and specific to general. Play a game with your family members. Play a game. Look at things around you. Try to form a general rule to a specific and a specific rule to a general. And that is an exercise that you can do. Wonderful exercise it will be. It will be fun and it will, polish your way of inductive and deductive reasoning. Then games. Please don't go for VTA, Vice City and games like that. PUBG. All these are rubbish. You play games like chess. It gives you a logical, it polishes your logical brain. So logical sequencing, strategizing, these are the things you learn through chess. Play chess every day if you want, Then, when you're playing chess, try to have a real chessboard. It's also possible to play online, but I would strongly recommend play it with, the dices you hold in your hand and then you calculate, then you put it in the right place. Do it with your hands. More neurons that are involved in any activity that you do, you learn it the better way. If you just click with your finger, more than that you will learn when you actually hold something and move it like a dice of the chess. Reading comprehension exercises of various levels of tasks help nurture scientific temperament. Reading comprehension, very, very important. Wherever you get a passage, read and try to answer questions from that. That helps you to understand a concept clearly. Riddles and brain teasers are all-time favorites that infuse excitement and challenge to analyzing and problem solving. So riddles, Sudoku puzzles, crossword puzzles, all these type of things you should practice day in and day out. If you have some time, if you want to relax, if you want entertainment, don't sit in front of the television or a video game. Practice these things. Sudoku puzzles, crosswords, riddles, it will help you. Scientific method, what does it include? I told you, first it starts with observation. How you see the things, that is where your attitude comes into play. I can see a thing and I can have a wrong observation or a mal-observation. I see something, I told you, I see a rubber pipe, I think it is a snake. It's a fault in my observation. I go close and check, then I understand, no, it is not a snake, it's a pipe. That's the right observation. So you learn how to observe things. Then question your observation. What I am seeing, why I am seeing this. Next is hypothesis. That whatever you think that why this is being seen or what is happening over there, how this is working, that is your hypothesis. After you form the hypothesis, you conduct an experiment. I told you, make a model of it, make a diagram of it, and then you experiment yourself that whatever the previous experiment told, can you do it alone again? Can you reproduce the experiment in your home, in your school laboratory? And finally, when you conduct the experiment, you will come to certain conclusions. And those conclusions you can write as your finding. So it starts with observation, asking questions, thinking and giving a hypothesis. That means an explanation of what is happening. Then you conduct the experiment yourself. Then you see what is happening and you come to a conclusion and you publish or write the results. This is how the scientific method works. Now, the last point that I will cover today is computational thinking. Even before you learn coding, you need to understand what computational thinking is. Computational thinking consists of 4 parts. What are these 4 parts? Decomposing, pattern recognizing, abstraction, and algorithm. Now, if you learn how to develop these skills in you, you will be a 21st century, scientist, learner, and a student. What is that? Decomposition. Decomposition is whatever you see, break it down into small pieces. I do not mean you see a car and break it down, nothing like that. Breaking down means you see something, you try to divide it into small components. For example, you are telling that I want to go outside and watch a movie. Okay, let's say we are not watching movies these days, it's pandemic. So I'm going to go to the school. So I have to go out my home and go to the school. So break it down into parts. So first is I will plan which day and what time I need to go out. Next is what dress I need to wear. Third is who will drop me to school. Fourth is what are the books I need to carry. Fifth is for how long I need to be in the school. Sixth is after I come back, or how will I come back? And then after coming back, what will I do with the knowledge that I gained in the school? See, a simple thing of going and coming back to school can be broken down into so many steps. So when you break down into small steps, you can look at steps and observe those steps and find out if you can do it better or you can do it in a different way. So that is called decomposition. Any problem that you have, you need to decompose the problem into small steps and solve those small steps so that the bigger problem gets solved. That's called decomposing. Then there is something called pattern recognizing. Now, if you see that, you all recognize patterns, I'm pretty sure. You must have seen the moment, let's say your teacher opens his spectacles and rubs the nose, you understand the teacher is getting a bit angry. Or, you watch your mother's face or a voice tone and your mother calls you with that particular tone of voice, you understand there is some problem. Probably I'll get a bashing now. So you recognize patterns, right? You know when your father's mood is good, when your mother's mood is good. Based on what? Based on patterns. You have seen that when your father or mother behaved in a particular way, they are happy. Or they did something, they are angry. When your mother is throwing around, utensils here and there, that mother is angry. Otherwise, the utensils wouldn't have made so much sound. But when your mother is singing a song and humming a song, you know that your mother is happy. So that is what is called pattern recognition. And science is all about recognizing patterns. The moment you see patterns around you, you will see patterns all around you. The moment you start recognizing the pattern, you have learned this concept. Third is abstraction. Abstraction is a big concept being told in such a way that is easy to understand. Example, a globe. The earth is not an exact sphere. If you go to Google, you will see the exact shape of earth if you give, it's not an exact sphere. But you have a globe in your house or your school, it's an exact sphere. That is called abstraction. Why? Whatever you need to learn about earth, that can be taught through that spherical globe. And it is capable of giving you the knowledge that you need in your class level. When you go to the higher levels of science, that time you may be using a real model of the earth, which is not an exact sphere. But at your level, it is, if it's spherical and a perfect sphere, good enough. Abstraction is more about a knowledge being shared in such a way that others will be able to understand it better. You must have traveled in a metro train. You will see the stations are written in a parallel line. Like first it will be, let's say, Sham Bazaar, then there will be Maniktala, then there will be Esplanade. I'm talking about a metro station of Calcutta. These are all Calcutta metro stations. So the metro stations are put in graphical form, and that is in form of a horizontal line. But you know that stations are not like that. It's not exactly horizontally aligned. Maybe one station is in the north of the place, another is south, but you put it in a horizontal line because you need to understand which is my next stoppage. For that, you need not go all around the map to find out where spot A is and spot B is. All you need to know is if this is station A, I need to get down in station C. so you need a line. That's called abstraction. Finally, algorithm. What is algorithm? Algorithm is you make a flow chart of things. If you're doing something, you make a flow chart, and that is called an algorithm. Now, why I'm telling you all these things? Because for coding, to make an app, to solve a problem, to critically think, to be creative, these are the 4 things that you need to develop: decomposition, pattern recognition, abstraction, and algorithm. And you know how to develop these things? Simple games, dumb charades. You play dumb charades, right? How is it played? For example, you act, and then you tell people to guess what movie it is. So when you do that, what is that? Can you tell me? When you act, what do you do? Let's say, you say like this. You show a heart, and then you do like this. What is the meaning? Can you tell anyone what movie I'm trying to point out? Maybe the students who do not watch Hindi movies will not be able to point out, but ones who watch other movies, can you tell what movie I'm talking about? I'm pointing as heart, and then head, and doing like this. Someone is writing mental, 3 Idiots. Yes, I got the right answer. Udgit gave it. Dil to pagal hai, right? So you are doing what? You're breaking down the movie, decomposition, dil, pagal, and then you're recognizing the pattern. If dil and pagal is there, what is the name of the whole movie? So that is how you can do it, and this is not applicable in form of movies only. When you do your job in future, you become a scientist, you become a computer engineer, you become an astrophysicist, all these things will be helpful. And you can learn all these things through simple games. You can learn these things by making a list of things, by map pointing. There are numerous games that I can talk about. I'm just giving a few examples because we do not have so much time, but I can tell you these knowledge sources can be gained easily just through playing games and simple activities like 1-minute speech. Your teacher teaches you something for the entire 40 minutes. You give a 1-minute speech. What form of knowledge is that? Abstraction. The 40 minutes concept, you are bringing it down to 1 minute and telling only what is needed. Abstraction. So these type of things will be needed in your professional world. You can develop through numerous activities. So if I get, maybe in later part of the, in due course of time, if I get a session with you regarding basic science, I will cover how many different types of activities you can do. So with this, I come to the end of the presentation, but very quickly I'll show you, as I promised you, some branches of science that you can be in. Now look, what are the different types of scientists that you can be? First, astronomer and space scientist. You know that Vikram Sarabhai Science Foundation, the chairperson, Dr. Madhavan Nair, is an ex-ISRO chairperson. ISRO is, the most prominent organization of India in terms of space research. Similarly, you must have visited a planetarium. If you have not done, try to visit one, and you will see that what are the constellations and different star formations are like, and you get a lot of knowledge about space. And if that interests you, you can, study space research in your future. This is a picture of Birla Planetarium located in Calcutta. I love visiting this place. I have been visiting this from my childhood, but I make a point whenever I'm in Calcutta, I pay a visit to Birla Planetarium. I love watching those shows and the stars. You get into a different world altogether. Then, if you love trees and plants, you can be a botanist. Botanists are the one who deals with trees and plants. Even the algae and the fungi, all these things are dealt with by the botanist. Then, if you love animals, you can be a zoologist, right? In zoology, you can be, someone like Salim Ali, who is called the Birdman of India. You must have seen the movie Robo 2. Have you seen the movie Robo 2, Robo 2.0? In that movie, there was a character of Akshay Kumar, which is inspired by the character of Salim Ali, who is called the Birdman of India. Salim Ali has written so many books. I'm pretty sure you will find one in your school library and read that. Then Steve Irwin, he's not there anymore. He passed away because of an accident that happened when he was diving inside sea, and a stingray he got pierced through the chest by the ray of a stingray, but he was a remarkable zoologist. And then the ones who deal with snakes and reptiles, they are called herpetologists. So herpetology is again a field of zoology. Similarly, the ones who deal with birds are called ornithologists. So zoology has different streams again. Then if you love earth, you love stones, rocks, then you can be a geologist. A geologist studies the earth, including rocks, soils, and how they are formed. And in India, the Geological Survey of India is a very prominent organization. And the research of excavation that happens and happened earlier also in terms of Mohenjo-daro, Harappa, different things that we have excavated, the Geological Survey of India and the Archaeological Survey of India, these two things are very important for the children to know. Then physicist, whether it's Isaac Newton, Albert Einstein, or Stephen W. Hawking, these are all scientists dealing with physics. Physics is, that whatever you see around you, if you want to know how that is happening, it is physics. So a physics solution tells the rays of the sun, how much time it will take to reach Earth. It will talk about the sound, what is the intensity of the sound. So anything that you see, hear, and feel around you, that is physics. Then, if you go and try to check out what these things are made up of, that is chemistry. So whatever is you're seeing around you is physics. What it is made up of is chemistry. And you can become a chemist trying to understand what makes up the things of the earth. And then anything that is living, I have not included here in the next slide, but anything that is living and it has a life. If you want to know about that life process, that is biology. So things that you see around you, hear around you, feel, physics, how the things are made up of, with what, it's chemistry. And if it is living, it's biology. If you want to know more about the life, it's biology. Then in biology, there are streams like oceanography. What is happening, under the sea and in the ocean beds and the sea beds, that's oceanography. Then meteorology, you have the forecast of rain, storm, when it will be a typhoon that is coming and hitting the shore, or when there is a earthquake going to happen. These things can be predicted by science today. And these predictions are being made possible by meteorologists. The weather forecast, when it is going to rain, when the rain is going to stop, everything these meteorologists decide. And they decide based on observations, pattern recognitions. Now here you see pattern recognition is so important. They see the pattern of the weather and then they predict whether it will rain or not. Next, biochemistry is a branch of science which deals with life science and the chemical composition involved in that life science, right? Microbiology is research and study of organisms which can be seen only through a microscope. They are so tiny. The acellular, unicellular organisms, parasites, bacteria, virus, all these things are there. And there are sub branches to that. For example, virus being studied is virology. Bacteriology is study of bacteria. Mycology is study of fungus, and so on. Ecology. Ecology is the study of relationship between living organism, including human, and the physical environment. So how we react to the physical environment and the physical environment reacts to us is the study of ecology. We say that ecological balance needs to be maintained. So what is that ecological balance? It's about the relationship that we have with the environment. So that study is called ecology. Then, of course, there is mathematician who, you can be an accountant, a banker, a computer engineer. So all these things require mathematics, operational research, actuary and insurance. All these requires mathematics. Next. So the 21st century skills involve three things: critical thinking, collaboration, communication, and creativity. These are the things that you need to develop yourself in so that you can work in teams in a research. You can communicate your research with the others you have to be creative and you have to think critically. So with that, I have shared a brief intro about what scientific temperament is all about, what are the different branches of science, and how you can develop a scientific temperament and computational thinking. Now, if you have questions, I'll take a few questions because it's already 12:25, but I'll definitely take a few questions. Give me a moment. I'll just need to put a message in one of the groups that I'll start a session a bit late. Give me a moment. And in the meantime, you can ask your question, and I would request Shivang ma'am to unmute them one by one, and if they want to ask something, we can take those.
Sure, sir. So thank you so much for such an interesting session. For specifically, if I may say, characterizing the traits that we need to develop a scientific temperament. You started off with healthy skepticism. That's very, very important. And also to be free from prejudice and bias, to be objective, to sort of have this open-mindedness and humility while sort of carrying out these scientific experiments. The willingness to sort of suspend judgment without sufficient evidence, to be rational while gathering the evidence and while evaluating the evidence that we have, and most of all, to be perseverant, right? If I may sum up it, like, a seed is not a seed because a teacher has told you it is a seed, or your parents or grandparents, or you've read it in a textbook, right? A seed, you realize it will give birth to a sapling or a plant if you sort of sow it in the soil, you water it, you put it out in the sun, and then you realize that, oh, okay, a seed does grow into a sapling. So that was basically what our session was about today, and you sort of beautifully summed it up. I remember you talking about algorithms and pattern recognition with the examples of, if your parents are sort of, there's a lot of utensil noise happening, or your father changes his tone of voice, you sort of are able to identify the patterns, and that's how you become more rational. You're not just being subjective, but you're objectively looking at the situation. To sum up what you said, there's this quote of Confucius that sort of comes to my mind. The philosopher, the Chinese philosopher, he said, "I hear and I forget. I see and I remember, but I do and I understand." And that is the most important part of sort of developing this scientific temperament. So thank you so much on behalf of all of us here for such a heartfelt session. We will move on to the question and answer sessions. I do have a few rules that we have been following for the question and answer session. So Hasni, if you could please move on to the slides. Is this the slide? Sorry, can we go back? Okay, I'll just quickly explain the rules. Now we do know that there are a lot of questions that have come into the chat box. It was a lot of fun going through each of the questions that you had. However, because of paucity of time, it sort of restricts our speaker from answering all the questions, even though I'm sure Dr. Swarup Datta would have loved to sort of engage in a conversation with each of you. But for obvious reasons, we can't take in all the questions. We have shortlisted a few relevant and contextual questions based on our theme for today. I know all of you have asked about space and black holes and wormholes and all of that. We will have sessions coming up for you. We have 4 more sessions to go, and we will be addressing these questions based on the relevant theme. So if your question is not answered today, we will definitely address it in the relevant session. So for example, if it's a space-based question, we will answer it in that session. If it was geology-based, we will answer it in our session on geology. All right, so today we're just going to stick to contextual and generic questions based on scientific temperament. Questions that are similar in nature have been clubbed to a single question. And our endeavor is to ensure that all of you sort of get a better clarity on the subject of a scientific temperament. Right, so if we're ready, we will move on. So I will just quickly share the name of the student and probably they can unmute themselves. One of the questions that came in was from Arthav Nadkarni. Arthav, can you hear me? Am I audible? Your question was, how does the scientific temper help us? How does developing a scientific temperament help us?
Wonderful. So this question is a very good question that has been raised. How does a scientific temperament help us? Now, I give an example. Remember that you are walking and you see a rubber pipe in front of you. You see, and it seems like a snake. Now, if you do not have a scientific temperament, you will run away from there and your journey remains incomplete. Why? It remains incomplete mainly because you see and you get afraid of things that is not true. So in our day-to-day life, when we are taking decisions, if we take decisions based on facts that are not true, we will not able to, move ahead. So to move ahead, to do certain things, you need to take decisions from time to time. And those decisions should be based not on assumptions, but on facts. If you take decision on assumptions, you will never be able to reach your destination. For example, you want to travel somewhere. So what you're going to do, you're going to check that, for example, you take a railway train. So you will check out if I need to travel from Bangalore to Mumbai, I have to take a train. Then you say that, okay, I have to take a train and there are trains, a lot of trains in the railway station. Let me pick up my bag and walk. I'll see it after that when the train comes. So you go to the railway station at 9 a.m. and then you find out the train is there at evening in the night, 9 p.m. Now all these 12 hours goes wasted. But if you're a scientific minded person, what will you do? You will pick up the timetable of the train, find out when the train is, whether it requires a reservation or not. Can you just go and board a train? So with that rational thinking, you will reserve your train seat. You will go to the railway station maybe half an hour ago or 15 minutes ago to catch that train, and then your time is not wasted. So two approaches. One is unscientific approach. You just go there and you think that train is there, I'll get up on any train. But if you're scientific minded, you know that you need to do a reservation. You know that train has to come at a particular time. Then you're going to make that decision of starting from your home at what time and to book the tickets early. So this is as simple as that. A scientific person will take all decisions based on facts and well-established knowledge. And ones who are not scientific minded, they will do things based on assumptions and whimsical nature, and they will meet more failures from time to time. They will waste their time, and that is not going to be in any way productive. I hope that answers your question, right?
Yes, sir. Thank you. I hope, Atharv, you've heard the question because don't seem to find you here, but if you have, please send us a message if your question has been answered. Let's move on to the next question. The next question comes from Alicia. Just give me a minute. Yes, Aliza Noor from DAV Public School, class 5B. Her question is, how can I inspire? Aliza, are you here?
Yes, ma'am.
Yes, please. You please ask your question. Thank you, Aliza.
Yes, sir. My question is that how can I inspire and motivate myself to become an astronaut?
Right. You don't need to motivate yourself. If you want to be an astronaut, you just need to tell yourself, I want to be an astronaut. That's it. The motivation is something that, you require when you don't want to do it. For example, I don't want to be an astronaut, then you need to motivate me that I want to be an astronaut. Being an astronaut is good. It gives you a lot of respect in the society. You learn a lot of things about the planets and stars. Only this motivation is needed when you don't want to do a thing. Once you want to do a thing, you don't need motivation. It will come automatically. Do you need motivation to, play something? Play a game, for example, or whatever you love doing? Do your parents need to motivate you? Come on. You need to play some games. You take out a video game and you need to play it. It's wonderful, good for your health and heart. Do they tell you that way? No, right? So you don't need to be motivated for things you already love. It will happen automatically. Don't worry. So you just need to understand and find out what you love. That's the only question. Ask yourself what I want to be. And once you are convinced, yes, I love this, all the things that you're talking about, I understand that by motivation, you said how I can prepare myself. If that's the question, that will automatically happen. Don't worry. When there is a will, there will be a way. So if you want to be an astronaut, all you need to do is, I'm pretty sure you will find out in Google, because knowledge is in the tip of your fingers now, that what it requires to be an astronaut, what is the, college or university that I need to study in, what is the name of the course that I need to study, what is the score that I need to get in my board examinations, if it has some sense or not. So it will happen automatically. So self-motivation is required only for things that you don't want to do, if someone is asking you to do that. But since you already want to be an astronaut, I can already see you in that dress. I can already visualize that you're wearing that astronaut dress and starting for, a distant planet in some part of the solar system. So is it clear?
Thank you, sir. Oh, here's wishing you all the very best on becoming an astronaut in the near future. Okay. Our next question is, we do have a lot of questions coming in. I'm just trying to shortlist one, but one interesting question that I found most of the students were asking was, what do you think is your opinion on who created space? I know it's a little philosophical question, but how big is
Who created
space?
space?
How vast is space, and who is the creator of space?
I will share a story about this. This is a very interesting story. Once there was a person who was traveling in a train compartment, and this person was reading a Bible. So when he was reading a Bible, there was a person who was sitting next to him, was peeping into the book that he was reading. He said, "What book are you reading, sir?" He said, "I'm reading Bible." "So, come on, do you still believe in this Bible and what, God and all these things?" "I am a scientist. I don't believe this. So, you should not believe in this as well. You should not read books like this. Think rationally, think logically." The person said, looked at the person again, started reading the book. Again, the person kept, disturbing him, that what is there in the Bible? What do you know about God? So he felt that he cannot read the book any longer. So he kept the book and put it in his bag and looked up at the person. He said, "What do you do?" He said, "I am a scientist. And that's the reason I discouraged you. Don't read these books. Read scientific books." Then he asked, "What do you do? Are you a priest or something?" He said, "No, I'm a scientist as well." "So come on, what is your name? You're a scientist, you're telling, what is your name?" He said, "My name is Thomas Alva Edison." He was surprised because by that time, Edison had so many inventions done. He was a big name in science. "So you are Thomas Alva Edison? I'm so sorry, sir. I asked this question to you. I had this desire of visiting your lab from very long time. Please permit me so that I can come to your lab and see how your lab is." Edison said, "Fine, come over tomorrow morning." So the next day morning, this gentleman who was a scientist came to Thomas Alva Edison's lab, and he was made to sit in the drawing room outside the lab. And there he found a wonderful model of solar system. He went close and saw the accuracy with which the solar system was, that model was created. So Edison came in. Now what happens is, whenever someone comes to a house, he tries to appreciate something to start a conversation. For example, lovely house, you have got good curtain. So this scientist thought of doing the same thing. He said, "Good morning, Edison, sir. This is a lovely model of solar system. Where did you get it from?" Edison said, "Which model are you talking about?" He pointed that model over there in the corner. "Well, I'm not sure. Yesterday it was not there. It's all of a sudden just emerged." "Well, come on, sir. You are a scientist. I'm a scientist. You're joking. Tell me who made it." "Well, honestly, I'm telling. There was nothing yesterday till last night. It emerged out of nothing all of a sudden." "Well, sir, please, jokes apart. You are a scientist. I'm a scientist. Please tell me who created that." So he asked them, "Now, do you believe that because there is a model of a solar system, someone has created it, right? It just not emerge like that, right? Like out of a bang or something?" He said, "No, it cannot happen like that. It cannot just emerge." He said, "If a model of the solar system cannot emerge without someone creating it, do you think the universe has just emerged like that without someone creating it?" So the moral of the story is, still the most popular reasoning or hypothesis of how the universe came into existence is, it is God's creation. Even keeping in mind the Big Bang theory, scientists like Stephen W. Hawking has a very popular book. In that, he has tried to show a reasoning why God has not created the universe, or how is it possible. But still the most popular theory is it's God's creation, because nothing can happen all of a sudden out of nothing. So this is what the message that Thomas Alva Edison, a scientist of his stature, gave to the world. I hope that answers your question.
Thank you, sir. That was beautiful. That is something that I think most of us sort of lean towards, that no matter how rational we are, we sort of tend to feel like, oh, if you're spiritual, I'm not using religious, but I'm saying if you're spiritual, you can't be rational. But I think it goes hand in hand, because eventually all the rationalists end up being spiritualists at one point or the other.
True.
Thank you so much. I think we've reached the end of our session. There are a lot of questions, but we obviously can't answer all of this. Thank you so much, sir, for joining us. Thank you for shedding light on the topic of scientific temperament and for answering all these questions. It was a pleasure to have you.
Thank you so much. And I can see the questions moving like a flash in the chat box. And I'm feeling guilty that I'm not able to answer all these questions. But one thing I would advise, children, I told you, start questioning and searching the answer as well. And in case you want to reach out to me, I have a YouTube channel. There are a lot of videos on that channel. Dr. Swarup Datta, education. If you type in Google, you will get my YouTube channel. From there, you can pull up my mobile number. And if you have something, you can WhatsApp me from time to time. If there are questions where you have reached a dead end, I'll try to answer your questions as far as possible. So surf out my phone number from Google, you'll get it, and reach out to me if needed. So thank you so much. It was lovely interacting with you all children, the bright scientists of tomorrow. And thank you, Suchitra ma'am, Vikram Sarabhai Science Foundation, Chivang ma'am, for making this session wonderful and allowing me to take this session. Thank you so much. Namaste.
Thank you so much, sir. Thank you. All right, we will move on. So Hasni, can you please turn the slide? Yes, so this is just basic information about your upcoming sessions. Our next session would be on, Suhasini, please, yes, on the 14th of February, which is tomorrow between 6 and 7 p.m. And our topic for tomorrow is climate change, yesterday, today, and tomorrow. And our keynote speaker is Dr. Ruturaj Fukan, and he is an expeditioner who has actually gone and visited the poles, right? So he is a polar explorer, and I encourage all of you to be part of this session tomorrow between 6 and 7 p.m. Please ensure that you join the session on time, right? And we'll see you all tomorrow. After the 14th of Feb, our next session would be on the 15th of February. Am I audible?
Yes, you are.
Yes, okay, thank you, Suhasini. I just lost you for a moment. Yes, so our next session after the 14th of Feb would be on the 17th of February, and our topic for that session is Earth Science, Geology, and its impacts in daily life. The timing for that session would be between 5 and 6 p.m. All of these details will be sent to you via email, so please ensure that you check your emails at regular intervals. Thank you so much for joining us. Namaste, and we'll see you tomorrow.